Hi and welcome back to Security Kitchen. My name's Ian and today we're going to be talking about brute forcing Android pins. Now previously we've grabbed the image from the device. We did talk about a Samsung X4. I've already grabbed an image of a Google Nexus 4. Now this is the a little cable that we use for the Rift box. Again, the JTAG port there. We've connected all that, and I've already dumped the two images. So first off is we've dumped the user data one, which contains all the sensitive information, and the metadata partition, which contains all the crypto information. So once we've got those two, we can then basically retrieve the PIN, which is also the encryption code. So what I've got here on my directory list in here, I've only taken an 8 meg dump just for kind of demonstration purposes, but you want to take the whole either 8 or 16 gig. So what I'm going to do, I've got two scripts, both these primarily by a guy called Thomas Cannon. If you do a Google for the scripts online, they're all available open source. If I just do the brute force droid, the two Python scripts, so Python brute force droids, and then this basically needs two files. So it's the header file, which is the 8 meg dump, and the footer file, which is the metadata one. So I put that in, and then just the max number of digits. We're going to start with 4. It is a 4-digit PIN, just for the sake of this demo. But what that's done, it's gone through and it's taken the actual information from the metadata. It's gone through and looked at all the crypto stuff, and it's got all that, and it's gone through and just for the sake of the demo, 1337 is the key. So awesome, we've cracked that. We can then, once we've got the PIN, we can then try and decrypt the data from the user data partition. Now we need another script for this, and this one is just called decrypt. Again, this one's by Tom Cannon. It's another Python script. So decrypt is the user data one again, which is the 8 meg dump, and then the 1337, which is the PIN we already know. So the script goes through and gets all the crypto stuff again, and at the bottom there you can see all the decrypted data. It is all zeros. That does mean it's actually working. I don't know why there was always massive amounts of zeros at the top of the user data partition, but you just got to trust me on this, it's actually working. Now I've already decrypted it. There is a couple of things, if you check on the blog, there's a couple of things you've actually got to do to the actual user data partition before you can actually start to read it. I think it's some of the slack space needs to be removed before you can actually mount it within the Linux operating system. I've already done that. I've already mounted it, and I've got it here already up and running in my unencrypted partition there. But what I quickly want to show you is how easy it is to start to retrieve clear text data. Majority of the information within inside Android applications are stored in SQLite databases, similar to the iOS type of stuff as well. So what I've got here is the email provider. So if I just quickly show you, load up SQLite and go email provider.db, and just quickly do select star from host auth, and this will, if it works properly, awesome. So there we go. We've got his email address there and his password, all in clear text. It's taken what, all of us, 5 minutes to do that. So things you can do to actually prevent this: update your Android operating system. I think it was from 4.4 they started to introduce the script algorithm, which basically slows us down. It takes longer to actually computate the hash, so that's a good thing. Also, make sure the pins are nice and long, at least 8, to actually slow down the cracking process. And pretty much, I think you need to take a second think if you're letting users onto your corporate network, the Android operating systems. Obviously, it's taken us 5 minutes to do this. What can a real-world malicious user do?